Alright, so in example 2, I've given you the exponential model that is examining the bounce of a ball as it's dropped from a height of 2 meters. So notice that the initial height, I've drawn a little sketch here, is shown in the equation as the initial value. It's the first number that's written down in the equation. And we see that in the diagram, the ball decreases its bounce in each successive bounce off the ground until eventually there's no more movement. And it's decreasing by 75%. So to answer A, this is definitely a model showing decay. And you don't have to look far to look for proof. It's shown right here in the bracket. That number is less than 1. 0.75 is less than 1. This has to be decay. It's pretty intuitive because we expect the bounce to get smaller and smaller as time goes on. N represents the number of bounces. So here this would be n equals 1, n equals 2, n equals 3, and so on. So that's the answer for A. If we look at B, I'm asking you what bounce, or after which bounce, does the ball reach a height of 0.63 meters? Well, that is the height I'm looking for, so we can go ahead and plug that in for H. 0.63 equals 2 times 0.75 to the power of n. Let's solve this exponential equation, just like we did in example 1. We'll use logarithms. Start by dividing out that initial value. Divide both sides by 2. And after we do that, we get a value of 0.315, which equals 0.75 to the power of n. So we have to use logarithms. 0.75 to the power of what gives us 0.315? Let's rewrite this statement by saying the log of base 0.75. And our big number is going to be 0.315 is equal to n. Right? So again, 0.75 to the power of n gives us our argument, our answer there, 0.315. We have to use the change of base formula. So the log of 0.315 divided by the log of 0.75 gives us n. And when you evaluate that on your calculator, you'll realize that n should be, if we round to the biggest whole number, n is 4. So the height of the ball is going to be 0.63 meters after the 4th bounce, which we can actually visualize in our diagram, would be right there. So here's our answer for B. Go ahead and try C. It's the same question. I'm just asking for what bounce does the ball reach a height of 0.11 meters. I'll go to a new page, and I'm going to just plug in, as I did before, 0.11 into the exponential equation, 0.75 to the power of n. We divide both sides by 2, and I end up with 0.055, 0.75 to the power of n. Again, let's use logarithms, so we know the log, using our base of 0.75. Log of 0.055 is going to equal n. Use the change of base formula. The log of 0.75 equals n. When you solve that, round to the nearest whole number, and you should get a value of 10. Those are the answers there.